Good morning to one and all. Today I am going to talk about quantum mechanics. So this is the module number 3 in the engineering first year, semester 1 or semester 2. Okay. So quantum mechanics. First I will talk about introduction part. So what is the introduction part for this quantum mechanics definition? You should know first. It is the branch of physics that deals with mechanics of particles or bodies in atomic and subatomic scales. So it can be nuclei scale or molecular scale also. That is called as quantum mechanics. So mechanics means movement of the particles or bodies. That particles or bodies can be atomic level or can be subatomic level, means nuclei level or molecular level and so on. That is, we talk only about microscopic particles, not macroscopic. Okay. Then here I have some concept map. You can see where is the role of quantum theory in different fields and applications. Quantum theory, it is applicable for quantum computing, lasers, communication field, quantum cryptography field. Quantum theory, it is also applicable in nuclear physics, atoms and molecules, physics, subatomic particles. Nuclear physics, by using quantum mechanics concept, we can design nuclear power, we can make nuclear missiles, atom bombs, nuclear bombs, and it can be used for medical purpose also. So there can be medical uses. Atoms and molecules, if we study at quantum level, then we can design different materials, and based on that technology can be made. And subatomic particles, if we study, then we can understand how the universe have been evoluted. So evolution of universe is from subatomic particles, and that is from quantum theory. So in overall we can say quantum theory is playing an important role in our day-to-day life. Okay. Now we'll go to the next first topic, de Broglie hypothesis. What is de Broglie hypothesis? De Broglie, he was French physicist. His complete name was Louis de Broglie. He gave some hypothesis, and hypothesis was dual nature. He suggested that matter like radiation has dual nature. Sometimes it behaves as a wave, and certain other times it behaves as a particle. So we can say that in proper statement, if radiation behaves as a particle under certain circumstances, like photoelectric effect experiments, Compton effect, there the light or X-rays behaves as a particle, and wave under other circumstances, like interpropagation experiments like interference, diffraction, polarization, their light behaves as a wave. Then one can expect even entities which ordinarily behave as particles to exhibit properties attributed to only waves under appropriate circumstances. Entities, it can be atoms, molecules, nuclei, etc. So electrons, protons, neutrons, and so on. So that also can behave, that is behaving like a particles, but that can exhibit wave-like properties also. So this was the hypothesis from Louis de Broglie. Then he made his hypothesis with mathematical equations, and he related that equations. It is if there is a wave is there, so particle is there, or particle is there, so wave will be there at microscopic level. So first of all, we should understand, before understanding the mathematical equations of de Broglie hypothesis or de Broglie equations of matter waves, what is wave and what is particle. It is not located at a definite point. Wave is a kind of disturbance which is produced in a region of space, and particle, it can be located at a definite point. We can locate it. Wave, it is specified by the parameters like wavelength lambda, denoted by lambda, frequency denoted by nu, amplitude denoted by capital A, intensity by capital I. And particle can be specified by its mass and speed, means velocity v. It can have therefore momentum, P is equal to m into v, and it can have therefore energy, half mv square. So after understanding this, there is a wave and the particle. They are completely different. Then also de Broglie, he suggested that matter like radiation has dual nature. So how he suggested that, and that can be correlated with the mathematical equations. So matter like radiation has dual nature. So he used the Einstein's mass energy relation. So using Einstein's mass energy relation that we know. So everyone knows about this. E is equal to m into c square, equation number 1, where E is the energy of the particle, m is the mass of the particle, c is the speed of light. Okay, so energy and mass conversion, and then using photon energy, which was given by Max Planck, using photon energy. So that can be written as E is equal to h nu. So it can be written as E is equal to h nu, equation number 2. Okay, so then we can say equation 1 and 2 both are energy only, left hand side energy, so that can be equated. So from 1 and 2 we can write from 1 from equation 1 and 2 we can write m into c square will be equal to h nu, equation number 3. Okay, because both on the left hand side energy is there. then it can be written in the next page. So as we know that new frequency is equal to c upon lambda, equation number 4. Substitute 4 the equation 4 in equation 3. So therefore we can get m into c square will be equal to h c upon lambda in place of nu. So once c and c will cancel out, speed of light, so m into c will be equal to h upon lambda. M into c is the means mass and speed of light, that is velocity, so that can be written as momentum. P is equal to, as we can write, m into c, equation number 5 this is. So therefore substitute 6 in 5, substitute 6 in 5, therefore we can get P is equal to h upon lambda. So hence we can write lambda is equal to h upon P. So this is known as de Broglie equation for matter wave. So this can be 7th equation, and so whenever we write momentum in terms of lambda, so we use this equation, or whenever lambda in terms of momentum we use it. So this is known as de Broglie equation for matter wave. Okay, why the name is matter means particle, and wave is a wave. And so here we can understand this lambda represents which properties? Wave. And here this momentum represents which properties or parameters? So it is a particle, it describes. So wave and particle are equivalent to each other, we can say that. So that's why if there is a wave, a particle is associated, or if particle is there, a wave is associated. This is known as de Broglie hypothesis. Okay, thank you.